we're going to start talking about solids today. The first thing that we are going to cover is KMT, or kinetic molecular theory. This theory actually started out first just to talk about the behavior of gases, and then eventually it was expanded to talk about the nature of both solids and liquids. Solids, your particles are constantly moving. They're not a fluid, so what that means is the particles themselves cannot slide past one another. So the movement that solids have is that your individual atoms or your individual compounds that are making up your solid, they actually sit there and they vibrate in place back and forth. So your desk is vibrating, your iPad is vibrating, the skin on your hands vibrating. It's not something that you really normally think about because solids are pretty stationary, but in fact, on the molecular level, everything's vibrating. The atoms and compounds inside a solid are usually more closely packed than liquids. It's usually pretty close, but most of the time, solids are more dense than liquids. One exception that's very common to this is that of water. Water is actually less dense as a solid than it is as a liquid, and that is why ice floats on top of water. Solids have very strong intermolecular forces. That is why the particles are only allowed to vibrate in place. And because the particles can't slide past and forth and the only movement they can have is to vibrate, they're more ordered than gases and liquids. If you were to go and break solids up into two groups, your two main groups would be amorphous solids and crystals. The difference is in an amorphous solid, your particles are arranged randomly without any order. So they kind of look like this, where your bonds between all of your atoms and how they're arranged, it's not really perfectly nice and neat and structured. Okay. These are also known as supercooled liquids, and they have no definite melting point. And we're going to talk about that melting point a little bit later. The other main class of solids that we have are crystalline solids, and these consist of crystals. And it's not necessarily the crystals that you always think of. So like a piece of tin foil or aluminum foil or steel is actually a crystalline structure. So it's not just these pretty quartzy crystals that we're talking about when we're talking about crystalline solids. What a crystal is it's a set of particles that are arranged in a neat, orderly geometric pattern that repeats over and over again. Okay, we can see that these are patterns repeating over and over again because what we have is we have a unit cell, which is that repeating pattern. There are several different types of unit cells and structures of different unit cells. Here are a few different examples: cubic, tetragonal, hexagonal. Cubic, if you ever look at salt, like big chunks of rock salt, you'll see the little cubic crystals. That's the shape that they're always in. They always break off in little cubes. It's a cubic crystal. Other crystals, they'll grow differently, and that's based on their unit cell arrangement. Crystalline solids have a definite melting point. When they get to a certain temperature, these particles that are vibrating back and forth in place, they're going to have enough energy to overcome the attractive forces with the other atoms or other compounds that they're near, to overcome the attractive forces that are holding them together and be able to move out of the rigid arrangement that they're being kept in. When this happens, the particles then can flow, or they can move past one another, and we're no longer a solid, but now we're a liquid. Your amorphous solids, on the other hand, they don't have a definite melting point. The reason why is because all of these bonds in here, these are all different. They're not nice and neat and structured and the same as they are in a crystalline substance. For that reason, these melt, or these, what are these? The amorphous solids, they melt over a range. So over a series of temperatures. So you'll see a melting point range for like 110 to 118 degrees is what it melts over. Whereas with a crystalline solid, it will be like a definite temperature. such as 108 degrees is the melting point.